Hi guys, welcome back. In the last lecture, we've added a new users table to the database schema. Today, let's update our Golang code to work with this table. And while doing so, we're also gonna learn how to correctly handle some specific errors returned by Postgres. Alright, let's start. First, I'm gonna create a new file, user.sql, inside the db/query folder. In this file, we will write two SQL queries to create and get users. They should be similar to the ones we used to create and get account. So I'm going to copy these two queries from the account.sql file and paste them to this file. Then let's change this function name to create user. This query should be inserted into users. Then the field names are username, hash password, full name, and email. We don't have to specify the password changed and created at fields because they will be automatically filled with default value by Postgres. Okay, there are 4 input fields, so we have to add one more parameter to this value list. Next, this getAccount function should be changed to getUser, and the query is select from users. Note that we don't have an ID column in the users table. Its primary key is username, so here we should get user by username instead. Alright, now the queries are completed. Let's open the terminal and run make SQL to generate Golang codes from them. Now back to Visual Studio Code. In the models.go file, a new user struct has been added. And there's a new file, user.sql.go, that contains 2 functions to create and get user from the database. Next, we will write tests for these 2 functions to make sure they're working as expected. We've already learned how to do that in lecture 5 of the course, so I'm going to create a new file, usertest.go, inside this SQL folder. Then I will copy the test that we wrote for the create and get account function and paste them to this file. The package name is db. Okay, now let's change this function name to create random user. This argument variable will be of type createUserParams. The first field is username, which we can leave as a random owner. The second field is hash password. Normally, we will have to generate a random password and hash it using bcrypt, but that will be done in another lecture. For now, I'm just gonna use simple text value here. The next field is full name. We can use the same util.randomOwner function for it. And the last field is email. We will need to add a new random email function to the util package. So let's open the random.go file and implement it. This random email function will return a string, which should be a randomly generated email. I'm going to keep it simple here by using fmt.sprintf to generate an email of the form some random string at email.com. Alright, now go back to the test. We have to change this function call to testQueries.createUser, and the output result should be a user object. We require this user to be not empty. Then let's compare each field of the output user with those of the input argument. Argument.username should be equal to user.username. Argument.hashPassword should be equal to user.hashPassword. Similarly, argument.fullname should be equal to user.fullname. And finally, argument.email should be equal to user.email. There's no ID field in the user table, so let's remove this check. Then the user.created field should be not 0, since we expect the database to fill it with the current timestamp. The last field we have to check is password changed. When user is first created, we expect this field to be filled with a default value of 0 timestamp. The e0 function is used for checking this condition. Then at the end, we should return the created user, and we have to change this return type of this function to user. Okay, now let's use this function in the test. First, we should change this function name to testCreateUser, and inside it, we simply call createRandomUser with the input testing.t object. The next test is getUser. I'm going to change this account1 variable to user1. We call the createRandomUser function to create a random user. Then this account2 should be changed to user2. And here we call testQueries.getUser to get the user with user1.username from the database. The output user 2 of this query should match the input user 1, so let's compare each field of them to make sure they are equal. First the username, then the hash password, the full name, and the email. For timestamp field like created at and password changed at, I often use required within duration to compare the values, because sometimes there might be a very small difference. Alright, the tests are completed. Let's run them. First, the create user test. It passed. Then the get user test. Also passed. Now, if we open the database using Table Plus, we can see there are 2 records in the users table. Okay, so the 2 functions generated by SQL work correctly. Let's try to run the whole package test. This time, there are many tests of the account CRUD function failed. And the reason is because of the foreign key constraint violation. This is something we expected, because at the time these tests were written, the foreign key constraint for the owner field didn't exist yet. As you can see here, we're just generating a random owner, and it doesn't link to any existed users. In order to fix this, we have to create a user in the database first. Then here, instead of a random owner, we will use that created user's username as the account owner. Okay, now it should work. Let's rerun the package test. All passed this time. Excellent. But note that this only runs all tests in the DB package. We also have more tests in the API package. So let's open the terminal and run make test to run all of them. We've got an error here because our mock store doesn't implement the db.store interface. It's missing some functions implementation. That's because when we run make SQL before to generate code, 2 new functions, create user and get user, has been added to the query interface. And the query interface is a part of the db.store interface. To fix this, we have to run make mock to regenerate the code for the mock store. After this, we can see in the mockstore.go file, the implementation of the getUser and createUser function has been added. So now the API unit test should work. Let's rerun make test in the terminal. All passed this time. Perfect. Alright, now let's try to run the HTTP server. Then open Postman to test the existing API to create a new account. First, I'm going to try creating an account for an owner that doesn't exist in the database. As you can see, we've got an error because the foreign key constraints for our account owner is violated. This is expected since there's no account with this username in the database yet. However, the HTTP response status code is 500 internal server error. This status is not very suitable in this case, since the fault is on client side, because it's trying to create a new account for an inexistent user. It's better to return something like 403 forbidden status instead. In order to do that, we have to handle the error returned by Postgres. Here in the createAccount handler, after calling store.createAccount, if an error is returned, we will try to convert it to pq.errorType and assign the result to pqError variable. If the conversion is okay, let's print out the log here to see this error's code name. Now I will restart the server. Then go back to Postman and resend this request. Now in the log, we can see the error's code name is foreign key violation. We can use it to classify the error later, but before that, I'm going to try to create a new account for an existing user. Let's copy this username from the users table and paste it to this owner field's value. Then send the request. This time the request is successful and a new account is created. But what if we send this same request a second time? Now we've got another error. Duplicate key value violates unique key constraint owner currency key. That's because we're trying to create more than one account with the same currency for the same owner. In this case, we also want to return status 403 forbidden instead of 500 internal server error. So let's look at the log to see its error code name. It's unique violation. Okay, now with this information, let's go back to the code and update it. Here I will use a simple switch case statement to check the error code name. In case it is foreign key violation or unique violation, we will send this same error response but with different status code. http.status forbidden. Alright, let's restart the server. Then resend this request. As you can see, the returned status code is now fault3 forbidden as we expected. Let's try changing the owner field's value to an inexistent username as before and resend the request one more time. We also get a fault3 forbidden status in this case. So it worked. Last but not least, I'm going to try to create a second account for this user, but with a different currency such as Euro. The request is successful. And in the database, we can see there are two new accounts linking to the same username. One account is Euro and the other is USD. Okay, so that brings us to the end of this lecture. I hope you have learned something useful. Thank you for watching this video and see you in the next lecture.